Assalamu alaikum everyone. Today we will test a Cutes Drive 7.5 kilowatt Cute Drive. This is a nameplate of our drive. Okay, this is a 17.3 ampere 13.8 kVA CD2004FG 7A5 means 7.5 kilowatt drive. Okay, this Cutes configuration, there was an issue in this drive about a phase missing. So one of the phase was missing in the drive. Okay, after diagnosing what we found there was an issue in a firing section of the drive. Okay, first of all we will look to the connection of the drive for a lab testing. Here you can see this is a 3-phase AC using through these bulbs, and this is a main power section. Main is turned on and other rest of the breakers are turned off. Okay, so series will come directly to here. This is a RST section of our drive. Okay, and as you can see this is the output section, so it's going to output of inverter, which will show on these bulbs. Okay, this cable is basically used to take 220 volt AC from this board to this controlling section board. Okay, now this is a power section, this is a control section, and this is a keypad. Okay, this ribbon is used to transfer all the signals from the microcontroller to the main board, that is a firing section, sensing section, and all other section. Okay, this cable is for sensing. It is just for basically low voltages, 5 volt you can see. Okay, and this is for thermal sensing of the board. These are the connections on the module for thermal sensing, and it is coming through this wire to this main controlling section. Okay, this is to sense to actually give a power supply to our firing section. And what's remaining? Okay, this is a relay. These are the resistor, fuse, and other resistors. Okay, what is the basic functionality of this drive when we turn on? Okay, internally the built-in module convert that 3-phase AC to DC. Okay, the DC is then shifted to this capacitor bank, which is here. This is a capacitor bank of drive. Okay, the negative supplied directly to the circuit on this point. This is the negative section, while the positive comes through the fuse. Okay, and applied here to positive section, while these positives are short internally. Okay, these are the resistor for starting current. When we start the drive, there is a high current flow through the circuit, so this is for safety. Actually a charging capacitor current. So when it get turned on, then the relays shift these resistors and directly supply flow in the circuit. Okay, so this was a simple brief discussion detail about how it works. Oh, now what we found here, when we turn on the drive, there was a phase missing. After observing here on the bulbs, we found that there was one phase missing, which was W. So we focus on this section of the drive, that is a W section. This is optocoupler and for W, and this is for V, and this is for U, V, W. Similarly, this is a common, which is negative power supply for negative firing of the circuit, and these are respectively U, V, W section. Okay, there was a W phase missing, so we found here after diagnosing that this optocoupler was faulty, so we replaced this optocoupler. Okay, and this is a controlling section, so simply we check all the loosing and other things. Sometimes it happens that if the ribbon is loose, this ribbon, so you will get one phase missing. Okay, to turn on your drive and to check your firing pulses, you have to simply, the one method is to remove your module and then check individually the firing using oscilloscope on these points after turning on the drive, and we will see in the next section how to turn on module, how to turn on the drive without module. But currently, if you want to check the pulses in this situation, you have to simply remove the cathode of this diode, which is right in near to D3, near to your fuse. So what it do, it simply sense the fuse. The fuse is broken, then it will give some feedback using this resistor, and this is a path. So using this optocoupler, it will simply give a signal to the drive, so microcontroller, that the fuse is broken. And to trick it, we have to simply short this output to the 220, so it will sense the fuse is not broken, while we will save our module by stopping a positive supply to the module. And even if we fire or we put the probes of oscilloscope, the gate will not fire itself and the module will not get damaged. So to save your module, you have to simply either remove the fuse, but it will give error, so to bypass that error, you have to do this trick. Okay, now we will turn on the drive and we will see the behavior of the drive. So this is a keypad, simple, and you can see how to check the drive by applying the default setting, and in the description you can see how to apply the default setting. Okay, drive is on. We set the initial frequency to 2 and we will press the forward button, and now the drive is turned on. Okay, it's giving output. We will increase the frequency, selecting 5, press set. The frequency is increased, so by this we can see there is no phase missing, all the phases are flowing proper. So this was simply a demonstration about the fault diagnosing and repairing of a phase missing of a Cutes drive. So this is our lab for oscilloscope and other things, and this is me. Bye bye.